What's up, everyone? Jason Turley here, back with more TryHackMe.com content. Today we'll be looking at the reversing elf room. You see here the completion is at 100%. I've already finished this room a while ago, and if you click on this write-ups tab, this is the cool thing about TryHackMe. Users can submit walkthroughs. If you ever get stuck or just need a hint, you can see my name and little icon right here. You can click on that and it'll open up a link to my website, my blog post. So if you'd rather read an article instead of watch a video, you can check that out here. Note this was over a year ago, so I've grown a lot since then, you've grown a lot since then. So the techniques I'll show today might be more improved than what was in that article. I'm gonna click on this little gear icon right here and then reset the progress. Yeah, restart everything. Let's do it over from scratch. And here we are. You see we're back at 0%. And we have 8 tasks to complete. With task 1, crackme 1, let's start with a basic warm-up. Can you run the binary? Click here, download task file. We're just gonna save it. Open up our terminal. I'm gonna make a new directory. What's in here? Make dir. Go to TryHackMe ls. I like to do this just to keep all the task files in one place. It went to the downloads directory. Let's move that here. ls.l. All right. File on crackme 1. All right, it's a 64-bit ELF file. ELF is an acronym for executable and linkable format. At least I think so. Let's do man ELF. Yeah, executable and linking format. So it's really just an executable file. If you're used to Windows, then you're familiar with the .exe file extension. Linux doesn't really have file extensions. They look at the header of a file, the first couple bytes. So all ELF files have a special ELF header that tell it that this is an executable. We also see that it is not stripped, so it might still have debugging information. Let's go back here. It says, can you run the binary? All right. So if I try to run this as it is, /crackme1, we get permission denied, and that's because the executable bit is not set. Do change mod +x for executable, and then the name of the file. Now when I do an ls-tech-l, we see that it is executable for everyone. Rerun it, and it prints out a flag, and it says not that kind of elf. Not the one from that Christmas movie that I think is overrated. Slam that in there, hit submit, and move on to the next one, crackme 2. All right, this time there's 2 questions to answer. Find the super secret password and use it to obtain the flag. Again, let's download this file. Yeah, I wish there was a way to automatically save it to a directory I want, instead of having to go into my downloads every time. Move downloads crackme 2 here. Let's make it executable. Oops. All right, you can tell it's executable because it's now highlighted in a different color. Let's do file, crackme 2. All right, this is a 32-bit executable this time. It's not 64-bit like the first one. It really shouldn't make too big of a difference. Let's run it, and it prints out a usage statement. So we did it incorrectly. It says crackme 2 and then provide it some type of password. All right, what's a good password, guys? Please sub. Access is denied. All right. What about just password? 123. Access denied. Alright, so this is where the reverse engineering part comes into play. Figuring out how this program works. So before taking a peek at any of the code, any of the assembly instructions, anything like that, we can make an assumption. Let me open up a notepad file. Alright, so I'm going to write some pseudocode. I'm going to make an assumption at what this program is doing. Right now, I don't have access to the source code. All I have are the executable. I can disassemble it and look at the assembly instructions, but it's good to have a mental framework for what's going on. So it's likely creating a variable. I'll just call it guess. And it's setting it equal to the user input, right? And then there's going to be a check. So if my guess is equal to whatever that correct password is, then it'll like print the flag. Otherwise, if my password is incorrect, it will print access denied. So that's what the program is likely doing, and this is some crude pseudocode. If it looks familiar, it's kind of like Python. This wouldn't run, but it's very similar. So what do I want to do? I want to figure out what this is, right? I want to figure out what the correct password is. And I'm assuming that there's an if statement, that there's some type of string comparison. We know that this is an ELF executable, which is usually written in C, not Python. So there's probably a call to string compare. Compare string 1 with string 2. To prove that, let's use a command called ltrace, right? Look at the library calls that a function, that a program is making. All right, it prints out the address of main, the main function, and we see that call to string comparison. We see string 1, which is what I entered, and then we see string 2, which is the correct password, super secret password. And here it prints out access denied. So this is the password. This is what we want. Let's slam that into our prompt here, our answer, and we got that correct. Let's rerun the crackme. And this time we put in the correct password, and it prints out access granted, and it gives us a flag. Let me just steal that here and move on to the next one. Use basic reverse engineering skills to obtain the flag. There's a hint. Decode the strings. Awesome. All right, just like before, we're gonna grab this, move, downloads, move it here, change mod plus X, anything that ends in 3. All right, we got it. File, crackme 3, 32-bit. It's stripped, so it might not have debugging information. It might not have what we want. Crackme 3. Let's run it. It also wants a password. Super password. Let's see if they did password reuse. Come on, even my Aunt Mildred got this one. All right. How about apple pie? Is that the password? Nope. And it keeps taunting us. Even my Aunt Mildred got this one. Well, she's a smarter lady than I am. Let's see if we can cheese it out with ltrace again. Oh, it prints out the usage. ABC 123. Oh, this is interesting. So we see the library calls. Sterling. Get the length of the string. The result is here. It's 6 characters long. 1, 2, 3, 1, 2, 3, 4, 5, 6. All right, cool. Then it calls malloc 12. Malloc is a C library call that allocates memory on the heap. Maybe we'll get into the heap in a later video. It's not too important. It calls string length again, and then it calls the string length of whatever this is. But it doesn't do any comparison. There's no call to string compare. Let me hit the up arrow and run this again. We see the address for that malloc call changed, but this stays the same. Let me specify that. Is that the password? crackme3 and then that garbage? No. Alright, what happens when I do string length with that? Now it allocates 16 characters and it calls string length on this. That's very interesting. The hint told us to examine the strings. So let's look at the strings command. Print the sequence of printable characters and files. And then you can give different options. For each file given, this command prints the character sequence that are at least 4 characters long. Or you can specify a number below. Alright. Cool. Let's quit out of that. Strings on crackme3. There might be a lot, so let's pipe it into less. Alright, we see that call to puts, Erlang, malloc, standard error, string compare. So there is a string comparison call. Usage password. We see this. The 2 equal sign at the end is a dead giveaway, is a hint that this is the base 64 encoding of something. So let's grab this and make note of it for later. Let's just copy it. Is there anything else in here good? No. Let's do base 64 tag D to decode it. Paste that in. Hit Control D to exit. And look what it prints out. For your second lesson, unbase 64 all the things. Cool. So that base 64 is just an encoding scheme, and the key word is encoding. It's not encryption. When you encode something, it's supposed to be very easy to decode it. It's not supposed to be a very difficult thing to do. But when something is encrypted, you want it to remain encrypted. Think about HTTPS, right? A secure website, or sending your email. You want that to be encrypted. You don't want anyone to be able to just access that. All right, we're zooming through. crackme 4. Analyze and find the password for the binary. We can look at the hint if we want. IDA or Radari 2. These are 2 reverse engineering frameworks. I believe IDA is more popular than Radari 2, but let me know in the comments below what you guys think. Analyze and find the password for the binary. All right. Let's open this bad boy up. I'm hit Control R to reverse search. MV. Let me just do crackme star here. LS. Cool. 64-bit, not stripped, so it might have some debugging information for us, maybe not. Let's make it executable. Same steps as before. Run it. This time the string is hidden and we used string compare. Let's provide it the password. Alright, that's not okay. Not okay. ltrace. So it used string compare just like before in crackme 2, I believe. My more secret password. So that was pretty easy. I'm curious, is it in the strings output? No, it's not in strings. I always like using the quickest method possible. The hint said to use a reverse engineering tool like IDA or Radari 2 or even GDB. But if I can just easily get the answer by looking at the library call or the system call with ltrace or strace, I'm just going to do that. I don't want to spend time reverse engineering something if there's not really a need to. crackme 5. What will be the input of the file to get the output good game? No clue what that means. Let's look at the hint. Again, alright, it just tells us what tool to use. Control R to reverse search. Move, yeah, ls. run a crackme 5, enter your input. This is cool. Always dig deeper. No idea what that means. Alright, that's not working. Let's look at the library calls. With ltrace. Scanf is going to read our user input. So these are memory addresses. That's very interesting. Just type in whatever. Oh, it grabs the string length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. And then it compares it with this. That's interesting. Let me do that again. Let me just type A, B, C. So there must be a for loop. It calls string length 4 times here. And I entered 3 characters. Here it did 1, 2, 3, 4. Here it called string length 12 times. So if I enter however many characters I enter, it calls string length plus 1. And then it compares it with whatever this garbage is. I wonder if this is the password. Is this correct? Enter your input, that. Good game. Huh. Alright, we're really cheesing all of this. We're not really doing any true reverse engineering at this point. I'm going to use strace, look at the system calls. Yeah, same thing. Good game. Here it calls write. Write is a system call. Up here we see put string. That is a function call, or a library call, rather. Does it matter? Not really. Alright, let me grab that value. Yeah, sorry guys. I thought this would be a more compelling video. I'm just running strings and ltrace on everything. Analyze the binary for the easy password. The hint. Alright, I could have guessed that. Clear my screen, hit Control R to reverse search through my command history. Make it executable. Same old, same old. File on crackme 6. Let's look at what we're dealing with. A 64-bit ELF. It's not stripped. Alright, let's run it. Crackme 6. Crackme 6 password. Good luck. Read the source. Alright, there is no source code. Sub and like. That's my password. Just sub. Sub not okay. Alright, can we cheese this yet again, folks? Alright, printf. Password is not okay. No, so we can't just look at it with ltrace. Can we look at it with strace? These crackmes are kind of easy to cheese out because there's always like there has to be a comparison. There has to be a check like this. Whatever the user inputted with the actual password, there's always going to be this logic check. And in the C programming language, C or C++, or maybe even C#, it's always going to be like a string compare, like this. Alright, let's look under the hood. I don't really like Radare 2, and that's simply because I don't know how to use it. Let's look at crackme 6 in GDB, the GNU debugger. We'll try to at least. It says that there's no debugging symbols found. Can I disassemble the main function? I can. Nice. So if this is your first time ever looking at assembly language, it can be a bit confusing, a bit ugly. On the left column, we see an address. This is a relative address. It's not absolute. We see all these offsets. Not too important at this moment. We see this middle column right here. These are the instructions, right? The cool thing about assembly is the name of the instruction tells you exactly what's going on. Push. So push this value onto the stack. Move. Move this into that. So set RBP equal to RSP. Subtract. CNP, compare. JE, jump if this thing is equal to that. Right? Call this function. I put out a video a few months ago about how to get better at assembly language. I'll leave a card here and a link in the description. It's really not that confusing to read. Can I write in assembly? Probably not anymore, but it's not too hard to read and figure out and parse through. So like I said earlier, there's always going to be some type of compare instruction. And in this case, we see this call right here on line 62. Compare PWD, compare password is what I'm going to guess. Let's disassemble that function. Let's look at that assembly code. All right. We see a call to something called mySecureTest. Then it compares these values. If they're not equal, go to line plus 40, which is down here. It's going to load some type of value into EDI, and then it's going to call printf. I'm curious if I can print this out, if that's like a string. I'm going to do x/s, examine a string, that value. Password not okay. We saw that earlier. So if the password is not correct, it'll check it here, and then it'll jump here. It'll load up the arguments to printf, and then it prints out password is not okay. But if the password is correct, it won't jump down because the jump skips these three instructions. So if the password's correct, it'll load this value into the EDI register. It prints it out, and then it jumps here, 62. It exits. So I wonder if this value, this string, is the correct answer, maybe? Or maybe I have to look into mySecureTest. Let's see what this is. Let's print this out. Let's look at the string at that address. Password okay. Sweet. So this is what we want. This is the case that we want. Let's look at this mySecureTest. All right, this is a big boy. This is a big function. We see a lot of tests, a lot of compares. Compare there. So AL, there's different registers, right? We see RAX. This is a 64-bit register. EAX is the lower 32 bits of RAX. And then AL is the lower 8 bits of EAX, I believe. If that made no sense, don't worry about it. So let's look at all these compare instructions. Compare OX31. All right, we see compare 33, compare 33, keep going, 77, 64. So if I had to guess, whatever password we enter, it checks each character one by one in some type of loop. It's kind of like implementing its own string compare kind of thing. That's why when I did ltrace, we didn't see string compare pop up, because there isn't one. They kind of made their own. So if I can grab all these right here, OX31, OX33, these are probably letters, right? All right, if I quickly reference my blog post from a few years ago, I'm gonna be lazy and just grab my answer here. Looks like I did use Radare 2 back then. So we see the mySecureTest. We looked at that in GDB. This is a long function, but we only need to concern ourselves with compare instructions. Each one compares the AL register, the lower 8 bits of the RAX register, with a single byte. We see a snippet here, and it looks like I put together a little Python script that has all those bytes, and then it just iterates and prints them out. So super lazy, or super smart, I guess. I don't know, however you want to look at it. I'm going to just grab my code that I wrote a year ago instead of redoing it. Quit out of here. Open up a little Python script. Paste that in. So I created an array called data, and it has all those characters that we saw before in the GDB disassembly. It's going to loop across each one. It's going to call the CHR command, which converts this hex digit to a character, a letter that we can understand. And it's just going to print it out. Python 3 solve.py leet pwd leet password. Grab you, go back here, and paste it in. All right, 2 more, guys. crackme 7. Analyze the binary to get the flag. Let's download it again. Nothing new. Control R, move, yeah. Change mod plus X. crackme 7. ls. File, crackme 7. 32-bit, not stripped, once again. All right, dynamically linked, yada, yada, yada. Let's run it. Ooh, we get a menu this time. 3 different options. Say hello, add numbers, or quit. Well, we're not quitters here, so we're going to say hello. We're going to do option 1. What is your name? My name is Pablo. All right, add numbers. First number, let's do 12. Second number, 8. 12 plus 8 is 20. All right, so this is just like a nice calculator. Can I do negative? Negative 9. And I don't know, 2. Oh, it does take negatives. All right, let's quit out of here. I'm gonna hit Control C. I'm not gonna hit 3 because we don't quit. So that's interesting. Let me do strings. Is there anything in here that we care about? We see it called a put string and printf. Oh, we see this. Wow, such hacksaw. We didn't see that prompt earlier. We didn't see that pop out. We see unknown input, unable to read name. So it looks like if you think outside the box, you can get it to print these different prompts. Unknown choice. Yeah, let's run this again. Let's do say hello, and I don't know. Let's just do a bunch of garbage. All right, doesn't care about that. What if I don't give it a number? What if I give it something like this? Please, it's the first number. Oh, I can't read it and it exits. Add number. Can I do like a format string attack? For my name. Can I leak any addresses like this? No. Let's exit. All right, let's open this up in GDB. I'm gonna do tac q for quiet. Don't print out all that license and description at the top. Can I disassemble the main function? Nice, we can. All right, it's pretty long. All right, looking through. I'm just gonna skim this. We see some values being pushed onto the stack. We see compare, letter 1, jump if equal. Down here, compare with 1. All right. Does anything stand out? Do we see any compare instructions or calls that we care about? Compare with the value 3. Compare with this value. That's interesting. Oh, we see this. We see give flag. Let me look at this value real quick. What is that? Can I just print it out? Elite 313. 337, elite. All right. If it's not equal to elite, go down to 5, 4, 5, 6. How did I mess that up? Subtract. Push this onto the stack. What is that? Examine string. Unknown choice. All right, let's look at this give flag instruction. Make note of this right here, the 3-1 through 3-7. That might be important. Disassemble give flag. All right, this is another big function. All right, do we see anything that looks like the flag value? Let's look for a call to printf. It probably prints out the flag, right? Put string. I'm gonna hit R to run the program. Say hello, add numbers. So we saw a comparison with elite. But when does it look for that? Does it look for that for my name? No. What if I add two numbers together? 31337 and 0. Elite. What if I just enter that here? Oh wow, that worked. Wow, such hacksaw. So that was a secret menu option, right? Elite. And it printed out the flag. Much reversing, very IDA. Wow. Well, we use GDB. Neat. All right, let's look through real quick. I'm gonna disassemble main again. Is there any other cool tricks? So this is menu option 1, I think. We see, I thought I saw a 2. OX2. Yeah, we see OX2 for menu option number 2. We see compare with 3. So those are the different menu options, and we did this one. Nice. There might be another one, like if I do menu option 4 or 5 or 1000, but I'm not gonna waste your guys' time looking at all that. Let's move on to the final crackme 8. Analyze the binary, get the flag. What does the hint say? All right, not helpful. Reverse search, move the crackme here. Make it executable. Let's look at it. Run it, give it a password, just some garbage. Oh, I added that little character, that slash at the end. Access denied, trace. Ooh, A2I. Some hex address, some hex address. What is A2I? Is there a man page for it? Convert a string to an integer. Interesting. So I think the A in this case stands for ASCII. So ASCII to integer, or ASCII to long, which is like a bigger integer, or to a long, a super big integer, super large. So the function converts the initial portion of the string to an integer, which is like a whole number. The behavior is the same as whatever that is, except it does not detect any errors. So what does that mean for us? We're usually entering ASCII, right? We're entering characters like ABC 1 2 3. Like these are characters, right? This is English. What we want to do is enter a number. Like a 1 2 3 4. It's going to treat it as a string, as an ASCII character, and then it's going to convert it to an integer. So our password won't be a phrase, it'll be an actual number. Let's see if we can leak it out with strings. Pipe that into less. All right, we're looking for any numbers, any digits. Nothing. Let's open this bad boy up in GDB. Disassemble the main function. There's that call ASCII to integer. Do we see any comparison? We see give flag, just like last time. Hit C to keep going down. All right. Compare. We see right here, compare cafe food. Let's print that out. Okay, we get this big number. So I'm assuming it reads our user input, right? Right here, it checks that we entered 2 arguments, meaning /crackme8 and then the password. If we did, it saves it into EAX, it pushes EAX onto the stack, and then it converts whatever we did to an integer, and it compares it with cafe food, which is this. So if I run the program with that as an argument, will it work? It just says access denied. I gave it an integer. So if it's equal, it goes to 103. What's on line 103? It pushes this onto the stack. What is that value? Okay. So it pushes this onto the stack, and then it prints out give flag. Let's look at give flag. We see a bunch of move and add instructions for these different memory addresses. In assembly in x86, if a register is inside these 2 square brackets, then that means you're accessing, that means you're dereferencing that memory address, right? This one is interesting. We see you compare here. Jump below. Go back to the top. So this looks like a for loop, maybe. Maybe it's iterating across some type of array. Some type of whatever our input is, it's iterating across that maybe. And it's adding to it and moving values. It's quite interesting. Let's disassemble the main function again. I'm going to set a breakpoint here. Break star there. Let me print out cafe food. Run with this value. Breakpoint 1. If I do a disassemble, we see this arrow, it points to here. Let me look at the stack. All right, let me do IR, inspect register. I believe my value is in EAX, right? That's what we saw here. That's what's going to be compared. Let me do NI, next instruction, disassemble. Let's look at the stack again. Let's look at the registers. So the value I entered is nowhere to be seen, right? I entered cafe food, which is just a hex value. I entered the decimal, which is this. Let's see why this is a problem. C integer So this is the problem, right? The max value for a variable type of integer is this. I can grab that. We can prove this with Python, right? You see that this value is less than that value, right? It turns out true. So this is too big. It doesn't fit in an integer. It's like if I have a 16-ounce glass, but then I try pouring a gallon of water into it, it's going to overflow. I can subtract them, and I get this 125,822. I don't see that value here anywhere, but essentially it wrapped over. It doesn't fit. So I think I'm comparing this value, right, the correct answer, but it's not actually working. So if I hit C to continue, let it run on, I get access denied because it's comparing two incorrect values. So let me rerun the program. I can run it with anything. I'm just going to do A, B, C, D. We hit our breakpoint. Let's look at the stack. Let's look at EAX. All right, we don't see our ABCD anywhere. And I. Look at the stack. IR. So we're at the compare instruction. IR EAX, does that work? EX is set to 0. I don't know why. What's in there? Number 2. Alright, I don't know where that ABCD I entered was. In fact, am I even doing this correct? Correct, set args. Help set args. ABCD. Run. Yes. Look at AX. We're all learning together, guys. There we go. So I never even set my arguments correctly. 4-1 is A, 4-2 is B, C, and D. All right, now I'm curious. I know this is too big to fit in an integer, but let me set args to this. Now rerun it. Yeah, start from the beginning. IR. Print out this value. We get this hex. Lots of deciphering. Alright, whatever. It's still too big. What was my point here? Let me disassemble. My point is you can set EAX, you can set the password to anything. Let's do NI. Next instruction, next instruction. Now we're right here. We're at the compare call. IR EAX. It's this garbage. We can change the value of EAX. I think it's just EAX equals that. Do you want the $sign? How do you do this? Let's go to Google, GDB, set registers. It looks like just set $sign register equals whatever. Didn't we do that? IREAX. Alright, EAX is now cafe food. We see that it's a negative number because it wrapped around. That's the point I was trying to get to here. Now when I hit C to continue, run the rest of the code, it should go into the get flag function and then print out the answer. And it does. At least this cafe won't leak your credit card numbers. Nice. Alright, so I fumbled around a bit with that last problem. Let me summarize it quickly. So normally we entered like a passphrase, a password, and that's what gave us the flag. In this case, it had A2I, convert an ASCII number, convert your string into an integer. That's all it did. But we had to give it the correct integer, which is cafe food in hex. In decimal, cafe food translates to this number that is too big to fit in an integer in C. It's an integer overflow. It was actually a negative number, as we see here. So in the debugger, we changed the value of the register EAX, which contained the variable, or which contained the value. We changed that to something else. We changed it to cafe food in the debugger, right? I can't do this normally from the terminal. You have to use IDA or GDB or Radare2. You have to use one of these debuggers to analyze the program dynamically. So we changed it, which made that compare instruction work, and then it prints out the flag. Let's go here. I fumbled with GDB syntax because I'm a noob, and slam that in here. All right, that's the wrong thing. Copy. And we're done. All right, that wasn't too bad. I know I used ltrace for a bunch. I think I used strings for one or two. And then even though the hint said use IDA or Radare2, I just feel more comfortable in GDB. If you look through the blog post that I have linked, I actually do use Radare2 a few times. So if anyone wants to learn that tool, this might not be a bad way to get acquainted. All right, I'm going to call it a night. I'm going to wrap it up there. I've been recording this for way too long. Hope you guys enjoyed it. Let me know in the comments below if you found a better or a different way to solve any of these problems. As always, take it easy and see you guys in the next video.